Hi, this is Mr. Warden. This is a video key for PreAlgebra Do Now, 32, comma 1. It should be dot 1, but that's okay. Week 32, day 1. And the first thing you need to do is find x and y. Well, the nice thing about this is it's a 45, 45, 90 right triangle. So y is going to be the same as what we've got here. So we can already start off with y equals 3 square root of 2. Okay, now let's deal with x. X is going to equal 3 square root of 2 times 2, so 3 square root of 2 times square root of 2. So square root of 2 times square root of 2 is just going to be 2, so that's going to be 3 times 2, which is 6. I'll say units. Okay, now we've got that one. Now let's take a look at the next one. We're going to find A and B for this one. Okay, this is a 30, 60, 90 right triangle, and this is our double side, so 2 to 1 to root 3. So let's deal with B first. That'll be the easiest one. B is going to equal 1 square root of 2 units, which I'm just going to write as square root of 2 units. And then A is going to be square root of 2 times square root of 3 units. So we can work that out. Square root of 2 times square root of 3 is going to be square root of 6 units. Okay, so it's square root of 6. So you can multiply, you can take the square root of 2 and the square root of 3, just multiply the 2 and the 3, and you end up with a square root of 6. How many opposite vertices? If we connect the opposite vertices, what kind of shapes do we produce? So what I mean by that is we're drawing a line here. That's opposite vertices. There's opposite vertices. And those are opposite vertices. So what we produce are 6 equilateral triangles. Okay, so if you have found a formula for the area of an equilateral triangle, a single one, then you also have the formula for the area of an hexagon based on the side. So it's going to be 6 times the area of a single equilateral triangle, since there's 6 of them. Now, number 4, consider these very well-drawn lines on this regular octagon. What is the relationship between the double tick mark segments and the single tick mark segments? Okay, how can you use that to make an area formula based just on a single side length? Well, this is square root of 2 larger than that. Okay, so single hash marks, or tick marks, I should say, are square root of 2 times as large as the double tick marks. Okay, so strategy. Break this into shapes. Okay. And use the side relationships. Probably a useful thing would be to just declare this to be side, and then these are going to be side root 2 over 2. Okay, so to declare the edges of the octagon to be, I'll spell octagon right, to be X or N or A in length. Then the double tick marks would be A square root of 2 over 2 in length. Okay, I'll put that in parentheses. Actually, I'll just put the multiplication star there. Okay, and so we've got 1, 2, 3, 4 little right triangles. Of course, each pair of them makes a square. So you've got we can start sorting things out. We have 4 45, 45, 90 triangles, which is 2 squares. Okay, we have 1 square. That would be a squared in size. And we have 4 rectangles that are each a by a square root of 2 over 2 in dimensions. And so if I multiply that times 4, I would end up getting 2 times a times the square root of 2, because the 2 and the 4 would simplify to just 2 over 1. All right, I hope that was helpful, and we'll explore that